Hello and welcome to another video following on from previous videos' work on parametric equations. What this video is going to cover is looking at how to find points of intersection and doing other geometric style problems. So, often points of intersection we're going to be talking about with the coordinate axes. Or maybe with another line. Or curve. In all of these cases, the general idea, or the most common way of approaching this is find t, or theta. Find whatever your parameter is. Now that may be easier for certain questions than others, for sure, but that's kind of the general gist. Remember, if we are crossing the y-axis, that means that x is 0. So in this case, we can set our x equation equal to 0, find t, substituted into the y equation. We're crossing the x-axis, we do that the other way around. With another line or a curve, that is a little bit more in depth. What we're going to do, so if we've got x is p of t and y is q of t, what we're going to do is we're going to take both of these equations and we're going to sub into the equation we're intersecting. Use that to find t, or theta, and then work it backwards to find x and y. So what we're going to do is we're going to have a look at a couple of examples to show you what's going on with those, and then I'll let you go off and practice. So this is our example here. We've got a curve given parametrically by the equations x equals t squared and y equals t to the 4. And then we've got a line that meets the curve at A, and we're trying to find the coordinates of A. So we know that x plus y plus 4 equals 0. We also know x is t squared and y equals 4t. So at the point of intersection, x is t squared, y is 4t, and we get a nice, relatively straightforward quadratic to solve. In this case, it factorizes very nicely into a perfect square. So we know that t is minus 2. All it needs us to do now is work out the coordinates of x, the coordinates of y, or the y value, and then the point of intersection. And it's as simple as that. Now obviously other questions, and the next example we're going to look at is slightly more difficult, but it's that general principle of using the information you're given generally to find an equation in t, to solve, to then find your coordinates. Now obviously this one was a quadratic, and other quadratics may not factorize so nicely into a perfect square. If that's the case, one of two things will happen. Either they'll ask you to find both points of intersection, or they will restrict the domain or restrict the values of t for this equation, so one of the ones you find doesn't work. So a couple of extra things to think about on top of this type of relatively straightforward algebra. This is the next example we're going to look at. A curve is defined parametrically by the equations x equals cos t plus sine t and y equals t minus pi by 6 all squared. And we're defining this curve strictly between minus pi over 2 and 4 pi over 3 for t. We're going to find the point at where the curve intersects the line y equals pi squared. Now the key thing to remember with this question is pi squared is a number, so this is just a straight line. Notice as well, find the point singular. This means most likely that we're going to get multiple values of, or possibly anyway, we might get multiple values of t, and we have to choose the right one. That's what I was saying before with the previous example of something you might have to watch out for. I need to change the wording of that question. Find the points, plural, where the curve cuts the y-axis. So before we have a look at this question, what I'm going to do is just show you very briefly how to use Desmos, which is a free online graphing program. I think it's great, to help you draw and sort of get your head around these questions. When you're working from home or at school or college, absolutely you can use this website and it works great. So let's just have a look here. This is the basic Desmos screen. So the first equation, the y equals pi squared, we're not going to worry about that for now. What we are going to look at is how to type in a parametric equation. So if we start typing in x equals and then some stuff with t's in, it doesn't like it. So what we need to do is write it as coordinates. So the x equation is cos t plus sine t. And the y equation was t minus pi over 6 all squared. Now it might take a little bit of time to get your head around typing things like this, but it is useful. Now you can see at the bottom it defaults and gives you a range of values of t to type in. So we'll type in what we've got there. So we can see minus pi over 2, and our upper limit was 4 pi over 3. So we can see that this graph looks really weird, but that's what parametric graphs do. They look strange. And you can kind of just use this to get a feel for what's going on. As we can see, because we limited the values of t, we have specific endpoints. And we've also got points where it crosses the axis or the axes, and we can see that's going to help us at least visualize what's going on with parts A and B. So if we want to see what's going on, so we can get an idea of kind of part A, well, you don't even need to necessarily write it in here, because y equals pi squared is a straight line. It's going to go across here. Pi is a little bit more than 3, so pi squared is a little bit more than 9. So you can see it's going to be crossing somewhere between 8 and 10. But there you go. We can see that we can pop it in there. Now, because this is done parametrically, even there, we can still drag points along. Now, with some graphs on Desmos, it'll give you nice points where you can just click on it and it tells you the answer. This one you can't, I think, because it's parametric. So that's just how you can use this sort of website. So you can see in the bottom right, desmos.com. Another similar one is GeoGebra, which you can use as well. I prefer Desmos. And you can just use that to get an idea, get your head around what these graphs look like. Obviously, in the exam, you're not going to be required to draw this graph because it looks weird. So going back to the question, now we've kind of got an idea of what the graph looks like. Pause the video, have a go at this question, and I'll show you and I'll talk through my answer. So we can see here my answer to part A. So common things that students are going to miss, this plus or minus. It's very important. We can see here we've got, once we recognize the plus or minus, we get two values for t. But this one is outside the interval. Remember, we're solving for t is between pi over 2 and 4 pi by 3. So we're going to ignore the minus 5 pi by 6. If you're worried about this, 7 over 6 less than 4 over 3, because 4 over 3 is 8 over 6, so this one's fine. Once you're there and recognize that we ignore this one, it's just a case of substituting the value we've got left into the x coordinate, or into the x equation, to find the coordinates. Now for me personally, I'd leave this exact. You could write it as a decimal, but I probably wouldn't. And here's my answer for part B. So notice it cuts the y-axis, as we've said, when x equals 0. So we set the x equation equal to 0 and solve to find t. And this is what I was saying here, we get two values of t. Again, we need to check that both lie in the interval and there aren't going to be any extras. These are both fine. And we can see that if we go backwards, so if we subtract pi from this, we get a number that's smaller than minus pi over 2. We add pi to this one, we get a number that's bigger than 4 pi over 3. So both of these are fine. And as we saw from the graph, we only have 2 points of intersection, so we found them. Obviously, you don't have a graphing program in the exam, but while you're practicing, again, you can use it to get your head around what's going on. Once we've found our values of t, we need to find the y coordinates, which, yes, they're not very nice, but they're there. Substituting minus pi over 4 in, we get 25 pi squared over 144, and substituting in 3 pi over 4, we get 49 pi squared over 144. Now, do be very, very careful with your layout. Because we're taking two values of t and putting them into the same equation, you've got to make it really clear in the way you lay out your answer which one's which. You can see here, it's very clear that this top line is when t is minus pi over 4, because I've said it. Likewise with the bottom, I've stated it. If I didn't do that, if I just jumped there, this becomes a little harder to see what's going on. Not tremendously, I'm aware, but if this equation is even remotely more complicated, you're going to start running out of space and it's going to get messy. So I would always advise writing down here when t equals something, and do the calculations from that. And don't forget to answer the question at the end. Intersects the y-axis at these 2 points. And that's it. Obviously, the geometric problems can get a lot more wordy, a lot lengthier, but this is kind of the basics of it. Substituting values in, finding values of t, and substituting those into one or both of the starting parametric equations. Thank you for watching.